Oh, hi, my name is Eric Jamois. Thank you for joining me in this ADMET Predictor interactive tutorial dedicated to calculating ADMET properties. So we will go through how to select properties for calculation and also how to set up your environment for multi-threaded calculations. Calculating properties is a very central aspect of using ADMET Predictor, so it is important that we cover this at a suitable level of detail. So as a quick disclaimer on the terminology for properties, there's actually a large number of things that we can put under properties. There are certain properties, or what we refer to as properties, or models of biological endpoints. So for example, hERG, clearance, or mutagenicity, again, those would be models of biological endpoints. Some of what I will refer to as properties may be physical-chemical properties, such as pKa or solubility. Under the same amalgam, we'll be talking about things that can normally be referred as descriptors, like polar surface area or topological indices. There are other quote-unquote properties that we're referring to that may be site of metabolism. Those are locations on molecules where metabolism events are predicted to happen. And there's also a bit of a differentiator between a simple property and a composite property. For example, something like ADMET risk is a composite property, and there are several properties that actually enter in the definition of our ADMET risk property. So again, apologies for the amalgam here between those various nomenclatures, but again, for the sake of simplification, I'm going to be referring to pretty much all of these as quote-unquote properties. So there are actually two places where you can calculate properties. There is the ADMET Predictor environment, and there is also MetChem Designer, which will actually allow you to calculate properties for up to 100 compounds. So in this window that I'm sharing, we're actually in ADMET Predictor. And so what I'm going to do is open a file which contains an example data set, and this is a set of 2,000 compounds. It is a subset of the enamine diversity set, which has slightly over 10,000 compounds. We could just as well have worked with the entire enamine diversity set, but for the sake of the example that we're running through today, this 2,000 compound subset will be sufficient. So we can load this set of compounds, and the identifiers are actually stored in the first field, in the first line of each record. So we'll just select this, and then we will load these compounds. It's a very fast process. So again, this is one of the first things that one does in ADMET Predictor. Usually is probably just to go and calculate properties. And there's actually three ways that you can access, or three mechanisms by which you can access this functionality, either through this ADME icon over here. So if you hover over it, it'll say ADMET properties, or under data, calculate ADMET properties. So that will open this window as well. There is also a Control R shortcut through the keyboard that will open the same dialog. So if you open this, you will get this Calculate ADMET Properties dialog box, and here, depending on which modules you license, you may get a different layout. But basically, the modules which you do not license will be grayed out the same way this user models section is grayed out for me right now. So again, what you see may be somewhat dependent of the set of modules that you are licensing. Now, out of this set, you can actually customize which properties you want to calculate. So this is an alphabetical list of the models of the properties that are available to you. And here there's no specific information on their affiliation to a particular group or a particular module. You can, however, do this if you go to this icon. So here it's alphabetical, but the second icon here will display these same properties in a hierarchical organization. And now you have them organized by the kind of properties that they may be related to the metabolism. They may be related to metabolism or physical-chemical properties or transporter properties or toxicity, etc. And there are also some which are descriptors like e-state keys, topological indices, etc. So now if you can open on, by clicking on this plus sign here, you can open what's under metabolism and turn on or off each one of these. If you want to turn everything off, then you click on metabolism here. That would turn off everything, or clicking on it would turn on everything. So if you just want to select a few, for example, you would just turn them all off and then select the ones you want, basically. So it's just and then you would be able to do that, for each single one of the of these groups. Okay. So now if you have a favorite set of properties that you want to use on a repeated basis, you can actually save a particular set or recall it from file. Okay. So for example, here, I'm going to recall from a file a particular set of descriptors that I've worked with before. So here it's labeled as ericlist.txt. It's a simple text file, and that contains a list of properties, which, for example, I want to use. Okay, so again, this is a very easy way to get back to a set of properties that you want to use on a repeated basis. So we're going to check them all here. Just say OK. Now another aspect of setting up the calculations for property prediction is these advanced settings here. And this gives you access to a number of options, including the ability to set the pH for these properties that are pH dependent. So by default, these will be calculated at physiological pH of 7.4. However, if you wanted these properties to be calculated at a different pH, for example, if you were doing some studies in gastric fluids or studying what the fate of the compound might be in a given compartment of the digestive tract, you could set this to a different pH. You can also limit the pKa values to whatever setting that you decide. There's also a way to exclude compounds that might have a large number of ionizable groups. And the reason you might want to do that is that these compounds can have a very large number of ionization states. So as large as 2 to the power of the number of ionizable groups. So again, if you have, say, a dozen ionizable groups, that's going to get to something rather large, and the software will end up spending a lot of time on a handful of compounds which may or may not be relevant to you. So if these compounds are relevant and you still want to do the calculation, that is the setting by default. They are not set to be skipped. If you wanted to skip these compounds, just turn on the skip option. And again, the minute that the compounds have over, in this case, 12 ionization groups, then they would be excluded from the calculation. So if we're happy with the settings, we can just proceed. And the way you proceed with calculations very naturally is by hitting the calculate button here at the bottom of this dialog box. So if we hit calculate, the calculation starts. Here we have 2,000 compounds, and in total calculating in the range of 100 and about 170 or so properties. This calculation proceeds in just a little bit over 10 seconds. So we're pretty close to processing about 200 compounds per second. And again, this is with all the properties being enabled. And for the record, actually having less properties, so if you turn off some of the properties, it doesn't significantly speed up the calculation. It'll pretty much still proceed at the same speed. One thing I should mention is that this setup that I just showed you to calculate ADMET properties, that does not include the pharmacokinetic properties that are part of the HTPK module. And the reason it is not is because these pharmacokinetics models are mechanistic models, and they're very different in nature from the statistical models, whether they're regression or classification models that are in what we just described. So again, they're not part of this setup. If you want to access, again, the pharmacokinetics properties, which are part of HTPK, that will actually be part of a separate tutorial, but these are accessed through either this %F icon over here, or through tools, PK simulation, %FA, %FB. Again, there by nature, it is a completely different setup, and that is why it is handled separately. So the calculations that you saw, they were performed on a pretty standard Dell laptop, and as you were able to witness, they were pretty fast. The secret to the speed is the use of multi-threading. On this particular machine, I could have used up to 8 processors, and that is set up under the preferences section. And so that is found in the file. If you go to preferences, you will see that there is an advanced tab over here, and under advanced, you will see maximum number of processors to use for computations. As I said, I could have used as many as 8 processors. I used 7 to be on the conservative side and leave 1 processor available for housekeeping of potentially other tasks on the machine. Now, if you want to determine what your actual setup, what your actual configuration is on your laptop, on your desktop, under the Windows text box, you can type system, and this will provide system information for your machine. So in this particular case, we go to the processor section, and you will see that I have an Intel Core i7. There are 4 cores, but what is relevant to this setup here is the 8 logical processors, and that is what defines the number of threads that we can have running. So, this is how you would determine this particular setup. Now, notice that we have calculated a pretty significant number of properties. So these are all stored in columns right now. Okay. Now, if you wanted, or if you feel overwhelmed by this large number of properties, you have these yellow tabs available at the bottom here where you can narrow down the set of properties that are displayed to a given group. So if you only wanted to see the properties that are associated with transporter models, then you would just click transporters, and that is the only thing that you will see. The rest will be undisplayed. Similarly, for toxicity and other endpoints, you would be able to filter it down to a manageable set. Okay, so mentioning that along the way. So as I mentioned earlier, there are two ways to calculate properties, or two user interfaces to which you can calculate ADMET properties. The first one, which we just saw, is through ADMET Predictor. The second one is through MedChem Designer, that is in situations that is for situations in which you have 100 compounds or less. And I'm just going to show you now to access MedChem Designer. It's very simple. There is a MedChem Designer icon in ADMET Predictor, which you can hit. This is this aldehyde depiction here. So we can very easily open MedChem Designer. As I said, it'll handle up to 100 compounds. Now we have a file with 2,000 compounds here. If you specify this file with 2,000 compounds in it, the software will actually happily comply, except that it will only load the first 100 compounds of that set. Okay, so now you have access to similar customization options as we saw previously in this wheel here, change settings. If you click here and you go to ADMET, you will see that you have a similar layout of what is enabled in terms of possible properties, and likewise you can customize the set of properties to a similar user interface as we just saw. So if you are happy with the way the properties are defined, you can simply hit the Add Me icon here, and the software will proceed swiftly to calculate the properties that are enabled for these compounds. Okay, so notice that this is a different layout to the layout we had previously in ADMET Predictor. It's actually the reverse layout, because we have the compounds in columns and the properties in rows, whereas in ADMET Predictor we had the reverse. We had the compounds in rows and the properties in columns. Some people like it one way, others like it better the other. The good news is that you have access to both. So I will just say that in situations where you have related analogs and you want to see quickly what the impact might be in terms of predicted properties, it's very easy to just very easily scan through these analogs and realize again what may be the results from certain chemical changes within a series of compounds. Okay. Since we're talking about both modes of accessing property predictions, I will mention in passing that ADMET Predictor and MedChem Designer actually use two distinct licenses for property calculations, and you were provided both of them. So again, that you could potentially perform tasks on both sides independently. Also, as a pretty significant benefit, the multi-threading mode only consumes one license of the feature. So what I just did on 7 threads, that actually only used one license of each of the modules that were used as part of this calculation. And so that's through the graphical user interface, of course, but multi-threading also works in command line mode. So that is very useful as well. There will be a dedicated tutorial to the licensing aspects. So again, I don't want to go in too much depth here. So this concludes this tutorial on the calculation of ADMET properties. I hope this was useful. Thank you for your time, and you have a wonderful day.